Okay, I'm going to work through your problems here on what we have. So I'm going to start out by factoring x plus 2, x plus 4, x minus 2. Double check because usually something cancels out. It doesn't here. So we have no holes. Cross that off. So to start out with the vertical asymptotes, there's one at x equals negative 4, at 1 at x equals 2. As soon as you get them, put them on there. Horizontal asymptote. The degree of the numerator is less than the denominator, so it's y equals 0. So we're talking about the x-axis. So I know my stuff's going to go in between all that. X-intercept is what makes the numerator 0. Negative 2. And then y-intercept is what, go up here and cover all the x's up to make those 0, and you get negative 1/4. That's a point right there. Okay, so now I'm ready to graph, but I can also go to my table and start my table at negative 6. I'm going to go by ones. So negative 0.25, negative 0.4286, error 0.20, negative 0.1 repeating, negative 0.25. I'm just filling in my table. Negative 0.6, error 0.71, 0.375, 0.259. So I have that. My table is now filled out. So I want to see if some things matched up. These should line up. If you had any holes, they would also show up as errors. When I graph it, remember, you put these points on here to make your picture better. So when you go to sketch, approach, but don't run into. And make sure you go through any points that you have labeled. So notice here I'm not touching the asymptote, I'm just running close to it. The last step is to determine domain and range. So going left to right, I go from negative infinity all the way till my first asymptote. There's nothing there, but it picks up from there, goes to my next asymptote, picks up from there, goes to infinity. If you notice, these values are what breaks up your domain. And the range is a little different. The range, you need to look at the graph. So for the range, the only thing I'm going to think about is there ever a place where there's not a point? Well, this little thing here in the middle, it never stops. Every y value is on there. So negative infinity to infinity. Okay, I'll do a couple on the back. We don't have time for domain and range questions. So again, I'm going to start an interval and then change them to set builder because I think it's easier that way. So I'm going left to right, and I would have points out here. So if you want, there's an arrow. If you want to extend it, if it helps you to see that, go ahead and extend it. I just want to know, is there a graph somewhere? So there's a graph everywhere. There's an open circle here, but there's a point right below it, and I'm going this way to the right all the way out. So my domain is negative infinity to infinity, and the way you write that, as long as you have a real number, x is an element of the reals. My range, if I go bottom to top, I have a point all the way from negative infinity up to where I stop here at -1. And I'm including that point. Then I pick up my pencil and I pick it up again at 2, not including 2, and then it's going to keep going up forever. So 2 to infinity. So the way I write that, y, such that y is less than or equal to -1 or y is greater than 2. So start in, it's not a function because I can draw a vertical line and hit 2 points. So I would say no, because every x is not paired with exactly 1 y. So that you can see it by the vertical line test, but that would be your explanation. For it to be a function, every x has to have exactly 1 y. You can have y's repeat, x's cannot repeat. Okay, let's look at, let's jump around a little bit here. Let's go down to number 6. So again, domain, go left to right, all the values out here, so -infinity, all the way until I stop right here, +3. And then it's done. So that's it. X has to be less than 3. The range, I don't start any values until 1. I don't actually include that 1. And then I go all the way up to 1, 2, 3, 4, 5, 6, 7, 8. That one does have a value. So from 1 to 8, not including 8. Or so not including 1. Yes, it is a function, and it's just the opposite reason. Every x is paired with exactly 1 y. Okay, let's go over to this crazy step function. We did one of these in class, but make sure you understand it. So when I go left to right, there's no values that are missing. I don't have to pick my pencil up without having a point when I put it back down. So I pick up here, there's a point there. I pick up here, there's a point. It goes all the way from here to here. So that's going from -9, including -9, all the way to 6, not including 6, because there's an open circle up here. So x such that x is greater than or equal to -9 and less than 6. The y values are a little trickier. Interval notation no good here, because there's just specific y values. -2, 0, 2, 4, 6. You could list those. It's really a pain in interval notation. So 0, so I just want to show those. Sometimes it's written like this. Just as a separate set. And yes, it's a function. Every x is paired with exactly 1 y. Okay, so you can finish the rest of those. We'll check them in class on Monday.